For millennia, we have looked at the night sky and seen a constant. We used the stars to navigate the oceans and marked the seasons by their positions, assuming the heavens were an eternal, unchanging fixture. But that sense of permanence is an illusion. 13.8 billion years ago, the universe began in an event of incomprehensible heat and density, with all the matter that has ever existed squeezed into a region of space smaller than an atom. To study this beginning, scientists launched the Planck telescope. It was built specifically to detect the oldest light in the universe, the faint afterglow left over from that first moment of creation. That birth set everything in motion. Hundreds of millions of years later, the first stars ignited, beginning an era defined by intense light and the formation of the first galaxies. This realization changes how we see the night sky. Instead of a static backdrop, we are looking at a universe with a measurable history, a specific, active window of time we call the Age of Starlight. That history is driven by violence. When the Sagittarius dwarf galaxy crashed into the Milky Way, the impact was so massive it punched a hole through our galactic disk and pulled millions of stars into long, trailing streams. But this collision also acted as an engine. It injected our galaxy with a fresh supply of cold hydrogen gas, the essential fuel from which all stars and solar systems, including our own, are born. To see what kinds of worlds these stars produced, NASA sent the Kepler space telescope into orbit. Its mission was to stare at a single patch of 150,000 stars, searching for the tiny signatures of Earth-like planets. The problem is that planets don't shine. Compared to the blinding glare of a host star, a planet is virtually impossible to see directly. To find them, astronomers use the transit method. As a planet passes across its star, it blocks light, causing a momentary dimming. This chart tracks that brightness. The dip's depth and duration reveal the planet's size and distance. While we can now map these rocky worlds, we are learning that the same forces that birth them also make their environments deeply unstable. Many stars exist in binary systems, where two suns orbit one another. For any planet caught in that gravitational dance, the orbits are rarely stable. Often, the combined pull of two stars creates chaos, shifting a planet's path until it is violently flung away. It becomes a rogue planet, a refugee drifting alone through the freezing void. But planetary ejections are only the beginning of the destruction. The stars themselves eventually reach a point where they can no longer sustain their own existence. A massive star is held together by a balance between its own gravity crushing inward and the light of fusion pushing outward. When the nuclear fuel runs out, that outward pressure stops, and the star collapses under its own weight to form a black hole. This stretches the fabric of space-time into an inescapable current. At the boundary, called the event horizon, space flows inward so rapidly that not even light can move fast enough to escape the pull. Anything crossing this line experiences spaghettification. Because gravity pulls more strongly on the object's base than its top, it is stretched into a string a single atom thick as the forces of the black hole overpower the quantum bonds of matter itself. These black holes are the final destination for matter. They lock away the universe's finite supply of gas and elements, ensuring they can never be used to build new stars or planets again. Because matter is being steadily locked away in black holes and dead stellar remnants, the universe is running out of gas. Each new generation of stars has less material to work with than the last. This timeline tracks the history of star formation. This chart shows a massive peak roughly 4 billion years after the Big Bang. Since then, the rate of new star birth has been in a steady decline, meaning the universe's most productive era is already behind us. Our own sun will burn out in 5 billion years. While the smallest stars can survive for trillions of years, the result is inevitable. Eventually, the last of the nuclear fuel will be spent, and every star in the sky will fade. This marks the permanent state of our universe, the Age of Darkness. It is an era of cold, empty space that will last for trillions of years. Knowing this makes our current moment remarkable. We exist in the brief window where there is still enough light to see, and we are using that time to decode the mysteries of the cosmos. That drive is why we launched the Parker Solar Probe. It is the closest we have ever come to touching a star, diving into the sun's atmosphere to understand the processes that birthed our world before the window closes. The age of starlight is a blink of an eye in cosmic time. Being alive in this exact moment, with the ability to look up and understand it all, is a rare and precious accident of history.